Hello! In this video I want to reduce this matrix to row echelon form and give you a little bit of sort of what I'm thinking as I'm doing it. So my first step that I'm going to do is I'm going to swap the first and second row. And my reason for doing that is that I really want a 1 up in this top left corner. And there are two ways that I could get it from what I see here. I could either multiply the first row by -1, just making that -1 into a +1, or I could multiply I can move the second row up. And the reason I'm choosing to move the second row up is because the second row has a 0 in the second spot, and zeros are really nice to have. So let's go ahead and do that. So we get 1, 0, 1, -1, -2 in the first row, and the second row becomes -1, 2, 1, 2, 1. And then the third and fourth rows are going to stay the same. 1, 2. Alrighty. So next, the reason I wanted a 1 up in this spot, so let's highlight the 1 and say we're happy with that. Alright, the reason we wanted that 1 up there is so that we can clear out everything that's below that 1. We can make all of those zeros. And the way we'll do that is I'm going to do it all simultaneously because we're just going to change 3 different rows. And so for the second row, we're going to add 1 times the first row to replace it. For the third row, we're going to add 2 times the first row and replace it. And for the fourth row, we're going to add 3 times the first row and replace it. Right. Now, the first row will stay the same. Everything else will change exactly 1 time. All right. And so what we get is 0, 2, 2, 1, -1 in the second row, 0, 1, 1, -1, -5 in the third row, and 0, 2, 2, -2, -10 in the fourth row. Alright, so excellent. We have our 1 up here, we have zeros all below it. So now, more or less, what we're going to say is that we're done with the first column, and in fact, we're done with the first row. We're going to stop using both of those things. Next up, we're going to look at the second column. So we want, in this spot right here, we want a 1. And right now it's not a 1. So again, we have 2 options. We could either divide that 2 by 1, or we could swap the second and third rows. And I think what I'm going to do is go with that second option of swapping the second and third rows. So let's swap those. And again, you can do either one, either will work. The reason I'm choosing this is because this way I'm not going to get any fractions. And let's all be honest, fractions are sometimes a little painful to work with. 0, 2, 2, -2, -10. Alright, so let's again mark off that we're ignoring all that row. We have our 1 here, so we're going to be happy about it. And then we're going to work to clear out everything below the 1. So we'll take row 3, subtract 2 of row 2, and replace row 3. And row 4, we'll subtract 2 row 2 and replace row 4. Alright, so first column, first row stay the same. Right, then the second row stays the same. The third row then becomes 3 zeros, a 3 and a 9, and the fourth row is in fact entirely zeroed out. Right. Excellent, so we're almost there. We're almost in row echelon form. We just have to multiply that third row by a third. Row 3. So we get 1, 0, 1, minus 1, minus 2, 0, 1, 1, minus 1, minus 5, 0, 0, 0, 1, 3, 0, 0, 0, 0, 0. Alright, and excellent. So if we want to, we can mark everything out. So what we see is that all of this is done. Mark all that. And look at that. We in fact can mark out this last leading one, and every leading one is in the right spot. It's to the right of any of the ones above it. It has zeros all below it, and the 0 row that we ended up with is at the bottom of the matrix. Alright, so yes, this is now row echelon form. Alright, so if that was the question, if all we wanted to do was reduce this matrix to row echelon form, we would be done and we would walk away. Now if on the other hand we had a question that said something like, if this were the augmented matrix of a system of linear equations, what are the solutions to that system? Alright, so let's go ahead and rewrite our matrix just to clean it up a little bit and write down our solutions. Alright. So we can add in our dotted vertical line to indicate the equal signs. Then we can even make notes for ourselves that our first column was x1, second x2, x3, and x4. Right? And if we again circle our leading ones and not add in those extra lines for clarity, we notice that there's a leading one in the first, second, and fourth columns. So those variables are going to be our leading variables. And in fact, this x3 variable, this is going to be free, right? So this is how we can quickly identify what our free variables are. They're in the locations without a leading one. So if we write our equations again, so x1 plus x3 minus x4 equals -2, x2 plus x3 minus x4 equals -5, and then that last line says that x4 equals 3, right? So already we know that x4 is going to be equaling 3, so let's label that. Okay, and then we can go back up and simplify these equations. So x2 plus x3 minus 3 equals -5, and x1 plus x3 minus 3 equals -2. Alright, so x1 equals, let's see here, so add the 3, so 1 minus x3, and x2 equals, add the 3, -2 minus x3. And so remember, we said that x3 was free, so x3 gets to be t in our solution. So our solution is right here, x1, x2, x3, x4. So x3 got to be t, x4 we found was 3. x2 from this equation up here says that x2 is -2 minus t, and then from the equation, the line above it, right, we see that x1 is 1 minus t. So that is how we would write the parametric solutions. Alright, So one thing that I would say is go ahead and answer the next question, which would be, if this instead were the coefficient matrix of a homogeneous system, what would the solutions look like? How many free variables would there be? And yeah, go ahead and practice row reducing as much as you can. Get some random matrices. I have some examples in the slides of how to generate some random ones, and just practice. It is very, very helpful to do. All right, enjoy.